Alright, this second example for shortest job first, preemptive. Now I've marked here, you have P1, P2, P3, P4 as usual, and I've marked the arrival time 0, 1, 4, and 8 milliseconds. This is their burst time. So let's start. So again, at 0 arrival time, only P1 exists, so P1 will continue, will start running, or let us put here the finish time like we did earlier. So at 0 milliseconds, P1 runs, and then at 1 millisecond, P2 arrives and a decision has to be made. So P1 has already ran for 1 milliseconds. So P1 has 1 milliseconds left, P2 4 milliseconds left. So P1 continues for 1 milliseconds, and then P1 finishes its execution. Now at this moment in time, 2 milliseconds, only P2 exists. P3 and P4 has not entered yet. So at 2 milliseconds, now P2 will start running. 3 milliseconds again. And when it reaches 4 milliseconds, then a decision has to be made. Why? Because then at 4 milliseconds, P3 has entered. So 4 minus 2 here, let's go to 2. And we find out that at 4 milliseconds, P1 is done, P2 needs 2 milliseconds, P3 6 milliseconds, so P2 will continue for 2 milliseconds because P4 has not even entered the fray yet. So P2 runs 1, 2 milliseconds, right, till it finishes its execution. 2. Okay, right. Now at 6 milliseconds, P4 has not arrived, P1 has finished, P2 has finished, only P3 has not run yet. So P3 now begins to run from P6, 6 milliseconds, 7 milliseconds again, and then at 8 milliseconds, P4 arrived. At this time, P3 has ran for 2 milliseconds, meaning it needs 4 more milliseconds to run. Now at this time, SGF again has to make a decision whether it continues with P3 or it starts with P4. So it checks P1 has 0 milliseconds, P2 0 means they have finished, P3 4 milliseconds left, P4 3 milliseconds left. So at this time, P4 is the shortest job, hence it will preempt P3 and start running P4. So now P4 will run for 1, 2, 3, and no other process there to hamper its execution. So here 3 minus 3, 0. And now P1 is done, P2 is done, P4 is done, P3 is left. Now P3 gets to run its entire 1, 2, 3, 4 milliseconds. P3. Alright, so if we have to calculate the average waiting time, so let's calculate. So for P1, the waiting time is 0 milliseconds. It did not have to wait, right? It got the CPU and continued until the end. P2, it got the CPU at 2 milliseconds when it arrived at 1 millisecond, so it has to wait for 1 millisecond. P3, it had to wait for 1 millisecond and it got to run till the end. P3 arrived at 4 milliseconds and it got the CPU at 6 milliseconds, meaning it has to wait for 2 milliseconds here. And the reason why I am putting a bracket is because it got preempted here by P4 and it ran again later. So now this is a little tricky. So see here, P3 arrived at 4 milliseconds. It got the CPU at 6 milliseconds, so it waited for 2 milliseconds. It ran for 2 milliseconds, it was preempted by P4, and then it has to wait this period of time. this period of time it has to wait before it gets a CPU again. So this period of time, how long is this period of time? From here it is 1 2 3 milliseconds. So we add here 3 milliseconds plus, now before, now it got the CPU at two separate locations, so that's why we have two values here for P3. P4, just once it got the CPU and it ran. Now it arrived at 8 milliseconds and it got the CPU at 8 milliseconds, meaning P4 did not have to wait at all. So that is our calculation for the average waiting time, which is 6 by 4, which the answer is 1.2 milliseconds. So this is the average waiting time for this